Okay, class, today we are in Miss Sky's 5th grade classroom, and today we are going to be doing a science experiment, and lately we've been focusing on water molecules. And so, can anybody tell me what a schema is? We've been talking about schemas, those things in our brains that we have. Can somebody tell me what a schema is? Do you know?
File in your brain.
It's like a file in your brain, and what do you put in that file?
Information.
Information. So what information do we know about water molecules? Do we know anything about water molecules?
They move faster when they get hotter.
Good, good.
Or slower when cold.
Yes, that's right. So hot water molecules usually move faster, and colder water molecules will move slower. And do we know what kind of energy it's called when it's temperature related? What kind of energy? Today we're going to be talking about thermal energy. So that's related to temperature. So today we're talking about how heat energy moves and how temperature affects the way water molecules move and speed. So in our experiment, we're going to be using 3 different temperatures of water. But before we start, I'm going to tell you all a little bit about what I expect. So one thing that I'm going to say during our experiment is 1, 2, 3, eyes on me. And that just means that you stop what you're doing, put pencils down, put anything that you're touching down, and you look at me, because that means that I'm going to be giving you really important instructions. And another thing is that we want to keep a safe space the whole time. So you all already have a safe space. That's awesome. You don't have anything on your desk except for your papers and your pencils or pens. So that is perfect. And we're going to use safe hands as well. So that means you all keep all of the materials on the table, not in your hands, until I tell you to use them. Second, you don't put your hands in the jars of water, because we're going to be using really hot water, and so I don't want you to burn your fingers. That would be bad. And we're going to be using this food coloring, and see, I'm already touching it a little bit, and it has a little blue on my finger. So we don't want to put the food coloring on our fingers as much as we can, and definitely not on our clothes, because we don't want our moms and dads getting mad about getting blue on our nice white shirt over here. And we don't put food coloring on our neighbors either. That would not be nice. Okay, so the problem that we're going to be answering today is, does the temperature of water affect how fast the blue food coloring will spread through the water? So we have our really hot water in this container, we have room temperature water, and then we have really, really cold water. And so why don't we talk a little bit more about how fast we think these different water molecules will be moving in the different containers. And we have our question on our paper, what do we know about the speed of different kinds of molecules? So why don't we talk amongst ourselves? You can ask me any questions and write down your thoughts about that.
I know that hot water molecules move faster.
Good.
At least I think so.
And where are we getting this information that we already know? Do we remember what that is?
Schema.
Yes, good job. Schema.
And cold water molecules move slower.
Mm-hmm.
It's frozen enough molecules not maybe, is that right? Or there's some
That's a good question. But you would think that if it's frozen, there's no movement. But particles are always moving, no matter what it is. But it's just very slowly. That's a very good question, Kate. Okay, 1, 2, 3, eyes on me. Let's put our pencils down. Thank you. Okay, so now we're going to be going into our actual experiment part. This is the exciting part. We actually get to use our hands and do something with our materials. So first, I'm going to just show you the materials that we have. I already talked about our 3 different kinds of water. We have a measuring cup that we're going to be pouring the water into before we put it into our jars. And then we have our 3 containers of blue food coloring. And then we have this pitcher where we're going to put the water after we're finished with it after each trial. So in our experiment, what we're going to be doing is we will pour the different temperatures of water into the different jars. And then at the same time, each of you are going to put 1 drop of food coloring into each of the jars. And we're going to all observe together the speed at which the food coloring will spread out in the water. So you all are already good. We're in groups of 3. And what we're going to have is we're going to have a hot water dropper. So we will, once we start the experiment, you all get to decide who wants to be our hot water dropper. That means who's going to put the food coloring into the hot water, and then our medium water dropper, who's going to put it into the medium or the room temperature water. And then our cold water dropper will put the food coloring into our cold water. Now, who can tell me what a operational definition is? We've talked a little bit about this. It's kind of a big word. We've talked about it a little bit. Can anybody tell me what that is?
An operational definition?
Yes, an operational definition.
That means like putting it into terms that everyone can understand.
Exactly. So what are some forms of measurement that we can use in an experiment usually? Temperature or time. So what are some ways that you can measure time?
The stopwatch.
A stopwatch.
Or you just
Do we
count.
use minutes, seconds? Yeah, those are some ways that we measure things. Now in this experiment, we don't have something that we're actually measuring that we can measure clearly like time or degrees and temperature. So we have to make an operational definition which will tell us how we measure how much the food coloring has spread. So how do you think we can measure that? By just looking at our jars of water.
Maybe when we feel like it's all blue.
When it's all blue? Okay, so why don't we say that the jar whose water moves the fastest is the one where all of the water turns blue first. Is that a good operational definition?
Yes.
Do we have that? Okay. Now can we jot that down on our papers so we remember that? Okay, 1, 2, 3, eyes on me. Let's put our pencils down. Okay, now we're going to be talking about our variables in our experiment. So, does anybody know what a variable is? Can we talk about
What is in the beginning of the experiment?
Yes, it's that one thing that we're changing in our experiment. So what is the one thing that we're changing in our different jars?
Temperature of the water.
The temperature of the water. So let's write down what our variable is. The temperature of our water in our jars. And now in an experiment, we always have that one variable that we change. But do we want to change a bunch of things all at the same time? No, because what could happen if we change a bunch of things all at the same time?
You don't know what is it in that actually.
Exactly. We don't know exactly what happened in the experiment if everything was different and we didn't have anything that was the same. So the things that we keep the same in our experiment is called our controlled variables. And so what are some variables, what are some things in our experiment that we want to keep the same, our controlled variables?
The amount of water.
The amount of water, and that's why we have our measuring cup, so that's good. What's something else? What about something that has to do with the food coloring? It's all blue, that's good. And you all can go on and write down these things as we're talking about them. Now what's another thing? Do we want to put 5 drops of blue in one and then just 1 drop of blue in another jar? Would we want to do that? No, because then we wouldn't be able to see which one was actually fastest. So once we write down all of our variables, our last thing that we have to do before we get to actually do the fun part is we come up with a hypothesis. And a hypothesis is just it's a prediction, it's a guess about what's going to happen. So what do we think might happen in our experiment?
It's gonna move. It's gonna use fastest in the
Okay.
water.
Okay, so why don't we, if you all want to talk amongst yourselves about what you think might happen, and write down your predictions.
If we drop the droppers in the cold water, it's not going to move as fast. It's going to take a lot longer for the jar to do.
Good. I like your thoughts here. We're using our schema. That's really good. Good.
So let's write down the prediction.
Yes, I would love you to write down your predictions, and it also says explain your predictions. So, why do you think that's going to happen? Okay, now whenever you're finished, I'd like you all to look up at me, put your pencils down. Okay. So the first thing that we're going to do is fill up 1 measuring cup of each of the different temperatures of water. So why don't we as a group decide who's going to be our hot, medium, and cold water droppers? So can we decide that?
I'll be cold.
It'll be hot.
There we go, perfect. Okay, I like the cooperation going on. That was easy and quick. Good job, guys. Okay, so can we have our cold water dropper fill up?
Are we doing it to the top or to that line?
Let's fill it up. That's a good question. Let's fill it up to the line. That'll be a little bit less messy. So everybody's going to fill up the measuring cup just to the line. There we go. And then can we pour it into our jar? And then we can go on. Here's our medium water.